case?
I got it, it's fine.
Oh, okay. It's really great that you brought your own laptop. You'll have more independence to do things. Yes, yes. And you may want to set up this environment. Like it's not required to come with laptops, but if you have like office and your workplace where you do things, maybe try to have it open there and connect. So we will cover at least these two red arrows, and we will need to find volunteers for like these four things. The presentations, I think if we would be in a real rush, we could do things tomorrow, because it's not as hard, but just to avoid stress, to prepare it slowly and use the weekend, we'll do it like next Thursday. So please try thinking of preparing your PowerPoint slides towards next Thursday, and I will ask to send them to me by email on the midnight before the presentation. The reason is that I upload them on the podium so that you do not waste time on putting in memory stick or logging into your account. Yes? From 11 to whatever it takes. Thursday, is it possible for you? Yep. If you have some conflict, you can come like not at the beginning, but a little later, and we'll put it at the end of the schedule. So I'll probably send it as an email. You just please think which of the subjects you want to present if you do not have one, and the lack of the interest or enthusiasm to the subject number one, maybe because it was not clear what it means here, like MOBA term, the basic Linux commands to open directory, things like that. So the stuff that we were doing at the meeting number one. So we will need a volunteer for the first thing. Okay, yeah. And this one will leave for next Wednesday, and maybe someone will vote on this. Yes? Excellent. I recognize your name when it is written, but I S-E? M? Okay, good. Yeah, thank you. And if you didn't select, just keep thinking what of the rest you may like. Do not worry. It's a very little simple exercise. And your schedule allows you Thursdays, or it is? You cannot? We'll find a way. Maybe just record you on Tuesday, or record you away from the class and just play during the class. But everyone else can come on Thursday, right? Or can make it at least for the special days. Okay. It will take me a couple of minutes to bring up this stuff, MOBA term, but if you do not, like some, I noticed that not everyone submitted the homework too, and you may use your time to like do it right now. You remember, you have these handouts, PowerPoint, just try to draw it in Gaussian. Are you done with building those? Or you need a little help? Models for homework too.
Yes, I haven't sent it, but I've done those. I haven't emailed them.
Oh, please do.
Yes.
And please open them right now. We will need them.
It's in my laptop. It's not here.
They should be here.
How? How do you open
Meg.
Is it one of them?
Yes, products. And
Okay, and you can open it in. Huh?
how do you open it?
How were you saving them? Okay. So I can bring this printout on the screen if anyone needs it. So it's those who didn't complete homework, we can do it right now. Just drawing these molecules in the goes here. And I'll make a circle and make sure that everyone feels comfortable. And if you have already done it, you may just bring them up to the screen because we will do some modifications to them. Let me just do something. Well, I'll probably. Can I borrow it for a minute?
Okay, sure.
Thank you. Try to draw this molecule, and please do not consider each other as competitors. Help each other. You need the image, or I'll bring it.
I just wanted to know how to put this side. I couldn't put that.
That's okay. That's okay. Yes, I remember it. And you can, yeah, thank you. Okay, yeah. Okay, excellent. Oh, do you
Take it up.
talk to each other. You'll find it better. Ask Gwendoline. She probably can. She's already an expert. Oh, you already got another one.
I borrow from Joe.
Okay, thank you.
It rotates, but it doesn't go up and down.
I don't know. But you can
I
just
tried. Yeah,
you can
I can
scale it up and
Scale it up.
yeah. I know how to do it in other software. Yeah. But you can put another piece on aside, right?
Yeah.
But you
Yes.
should draw them separately. And
It's
then-
it's one model of the all the
so
things
how should we?
No, it is one model, one file, another file,
Oh, these are two different.
two different files.
And how to adjust the number hydrogen?
Hmm?
How to adjust the hydrogen if we add another bond here? This hydrogen will
You can delete it.
just delete it?
Yes. There is a little cross.
This one?
Yes.
It will delete all the molecules.
No, it will do it, and then click on select this one.
Right? Click.
Just no. Oh no! This yes. Okay.
Built this whole model properly, but I don't know why there is a double bond here and this got separated. Same thing happened in my product as well. A double bond automatically appeared. I don't know how.
Can I do something? So you select.
Sorry.
It's okay if you need to answer. So you select a bond, and instead of modifying it, you can just change the. Okay.
Another question. Why can't I delete a bond here? If I want to
You-
delete it, how do I delete this bond?
Same.
Without changing, can't I delete it?
You can
I'll
just.
none. Okay.
Oh. Okay. And please share these little tricks to each other. It will be so much quicker. Let me attract your attention for a little trick that will take. It will not about drawing. It is more about processing files, and it is one of our tasks for today. So it will take maybe 3-4 minutes of your time, and then you can return back to enjoying the drawing. I imagine myself getting the same task for the homework, and I would feel very irritated and angry on the instructor and protesting. Like, why should I make a screenshot of an image? Why cannot I send the file so that the instructor draws it himself, right? So the question is, you all can access these files that you generate on the server. But can you take this file and send it by email? Can you share the files between each other to someone who doesn't have access to the same cluster? How do you take this file? So right now our hands are tied. We cannot do everything. We need to not only modify these images, but we also need to copy files maybe to local computer, send it by email, and do things like that. Later on, we will connect not only to this little pathetic server, but to some powerful computation tools, and we need to transmit files like this, files for your reactant and product, between different computational systems, right? So there are two ways. So one is very simple, efficient, and silly, and it will be big temptation to use only the first method. Everyone will learn it in 10 seconds, but please look at it. But then I will invite you to look on something very unnatural, torturing, unpleasant, but useful in general. So absolutely, absolutely. suppose I want to send this file to everyone in the class by email. And this is a quite small file that one can just copy and paste into email. But what if it is like 100 or a couple of thousand atoms? It will be possible, but it is a little non-usual to copy paste, right? So I'm doing an example that can be done very simple, but we know where it is located. We can type pwd. But how does it help? You see a little panel on the left, right? And one can just navigate there and find this directory in this file. So I'm just scrolling, looking for shared, practicing a little patience. Then looking for the user chem676 and looking for my name, and then this LAB3. So there is this ethane XYZ. So I can just click on it and pull it to wherever I need, right? So it just brings it to the desktop, and then you know what to do with it, right?
What was the last step?
Just drag and drop. So you click and move, right? And then you can open the file if you maybe like with Notepad, and you see that it is a text file. In the same way, you can modify file in your preferred text editor and then upload it by drag and dropping. So it is probably what is very tempting way. Please practice it and maybe send some file of your model to yourself as an email. Maybe later we will design a homework. I will ask you to send it to me via an email. But please practice and walk around. It's quite simple, but it's one of the vital skills. A little hint: if you are drawing something and you need to make an interruption, save file before you do some other task, because who knows what happens. It's better to save as often as possible, maybe with slightly different names. You know how to drag and drop files. You already tried it. Good. No? Try it. Click on this.
I saw it.
But please try to practice it. Yep. Can I help? And then some file that like
PDB files?
well it doesn't right now. We are just practicing. You can any file. Let me bring this one. You can just drag and drop it. Okay. Oh, thank you. Can I try something? Broomstick. a little bit. Yes, it's still from your chemical intuition. You may see that it is not ideal. You'll do something with it. But let's practice. Let's save. File, save. Just give some name as whatever reactant product. Okay. And let's try to bring into your desktop or some other place on your so it should appear. Okay. Yeah, please keep doing what you're doing, but I'll. You basically you got this. What else? Were you able to bring the files to the desktop? Yes. Okay. Okay. When you're opening, it may ask which application to use, and you may select like more apps, like Notepad will be okay.
Oh, okay.
It just misinterprets the line breaks. Also. You did it?
So where should we drop what?
Let me just do it. It will be. I'm not the explain the words quicker. I just. So you have file. Just click, move, release.
Oh, so that's it?
That's it. Yes.
Oh,
No,
I
no.
didn't know what you mean. Okay.
So it's. And if you want to look inside, just maybe.
Oh, also. Okay.
Okay.
Thank you.
Were you able to drag and drop files?
Yes.
Yes. You both?
Just dragging the files and drop.
But were you able to drag and drop files to the desktop?
No, I
No?
didn't try.
Machine control.
Okay, so
Let me do something here. So let's go down to shared, so that you go to the same directory. Which one? No. Which?
Yanta is my name. Yeah.
Okay. And you just click, move, release. And now it's here. And you can more apps. So it is here. Okay. And now you can send it as a attachment to the email, right? Like if you do something for research to your advisor or to each other. Were you able to migrate files here?
No.
No. Okay. Let me show it. It will be so much quicker.
So I saved it in my folder, okay?
Yes. Yes. So let's navigate in. This is like regular file.
I thought that when we switch to this directory,
No,
it will show
no,
here.
no. It's not as smart. It's a stupid robot.
Shared, clean, right?
Yes.
Click on okay. One and two.
And you just take some just example. Click, move, release, and open with some.
What time?
Okay.
Thank you.
And
Where was that?
just put bromine as atom.
I lost it. Can't find it.
Okay. So one can just follow. So look for home.
Shared, I found it.
You see the rest, right? Okay, thank you. So please keep enjoying to draw the models, but I'm going to, and I see that everyone got this little skill how to get the file so that you can later process it by sending an email. Now I'm going to show another way to do the same operation, to pull a file from the cluster to the local computer, and it will be the same operation, but it will be much more painful and unpleasant for humans. But it is more general and will be beneficial when we deal with supercomputers, when we need to transfer file from one supercomputer to another one. So the command that we are going to practice is here, and I will do not worry if you do not see it. I will copy paste it in a bigger font. So the command itself is SCP, which means like secure copy, then space, username on the cluster, at name of the cluster, colon, and then the whole path to the file, and then slash and file name, and then oh, it is here. File name, space, period. And then you click enter, and it may or may not ask the password, and then it will bring the file that you indicate from this remote cluster and this directory tree to your local computer. Before we start practicing, there is a little detail that throws mind off for many people. Where at the local computer? Because local computer has also a very rich tree of subdirectories, and how do we know where it will bring? So before making this operation, I'll probably open another window and try to navigate to a desktop that we all can access then by a mouse. So it will be not trivial but possible. So pwd. If I open MobaXterm and if I do not connect to the cluster from this command line, it means I access local computer in the Linux environment, typing commands, right? And by typing pwd, it shows where am I. If I want to access general disk space, I can do cd c colon. And you know, on the Windows DOS computers, there are like drives C, D, H. And then there is a subdirectory users. So if I will try to write file somewhere else, it may not permit me because I do not have administrator password for this computer. So I'm doing cd users ls, and it shows when you did log into the system, it will show your name. It will be different. I'm going to my name, but metric event, but in each individual computer you will see something else. And then if I'm doing ls here, there will be desktop. So it is a path to the desktop on this computer. So I'm doing cd desktop pwd. So right now I am accessing the disk space corresponding to the desktop on this little Windows computer from the command line. And I can check what is located there. So something is already there. Now I am going to the cluster and looking in which directory files that I need are located. So I need to, if I'm a crazy workaholic, I can look here and try it letter by letter. But it's kind of crazy. I better just copy paste the whole line, right? So I'm copying this path where the files are located and typing here SCP, which means secure copy space. Then I need to name the user then column, and then I'm clicking the middle button on the mouse and it pastes the path. So for each of you the path will be slightly different. And then I do slash and give the name of the files that I want to copy. Like, for example, reactant. And then I'm doing space, period. Period means right here into this directory. And then click enter. So in this MobiX terminal, it does memorize the password once you typed it once. In some other environments, this command may require you to type the password over again. So it's a little ancient and discomfortable, but it is quite universal. So it will work for between majority of computers and the Linux environment. Let's check that I was not lying when telling it. If this operation was completed correctly, then this file schema-reactant.xyz should appear on the desktop of this computer. See? Schema-reactant. And it is like about 30 files with silicon and bromine. That is a little less comfortable to copy paste. It's better to process as a file. So please try to practice this command, because it's not a way to torture young people. It is a practical skill that we will use repeatedly through the class. When these mouse operation commands are available, there are ways to avoid it, but there are sometimes situations when this old-fashioned copying of transferring of files is not, you cannot do anything else.
Show the comment.
Absolutely. So please try to practice this command, and I'll make a circle around the class and check how it goes. Opening new directory and cd users. Then you do ls, and you see this mahic. So cd LS, and if you scroll up, you'll see there's a desktop. So CD desktop. Okay. Now we need to get some files from here. SCP secure copy user at colon path slash and then like for example rectance.pdb space period. And see, it is here. Now you can send it as an email to someone. Okay. Did you try to transfer file by this crazy method? Not yet?
Yeah.
Let's try if you didn't. No. Right now you are on the photon cluster. There was no reason to practice it. We need to open another window. So that you are located on this computer, not on a photon. Now we are in this home mob extern. CD to C colon. And if you typically use.
There is no C.
Huh? There is Windows C drive, right? PWD. Now you do ls, you say users, cd users, ls, more, md, okay, ls, pwd, and now from here, if you scroll up, there will be desktop. So you cd desktop. Now, in this window, you are on this computer.
Okay.
And now your SCP, you can copy something from there. Photon.
From the remote computer to here.
Exactly. DCU. Column. Then we need the path. Where is your directory? Which of the directory is yours?
Large.
Okay. So you need to save your files in your directory, not outside. Directory slash, then we need, let's say, like, I don't know what is inside this file, but let's copy it. Copy into here. Let's look. Okay?
Yeah. Thank you.
Pleasure. Did it try? Did it work?
I think I'm missing a few steps.
Okay. Oh, okay. Let's swap. You can take another one. Thank you. So, in this window, you are at the photon cluster. And we need to access your computer from the same environment. So I'm going to this new window, new session. I need to think. Oh. Go over everyone else to help when it is easy case, and then return back to you. If you have, if you want to entertain, you may read some forums, but there is no guarantee that they have. Sometimes it helps. Sometimes not. There is also a way, if one closes and reopens, it will start working, but then the windows will close. So if you decide to do so, you may want to save everything prior to that. Okay. So you didn't. C.
Oh, I didn't save it in my file. In my.
So desktop is quite universal now. Okay, let's look into once again. Did I close it? Maybe I need to repeat all these things. How do you do paste? If I want to copy this line and paste it here,
Don't you?
last time when I tried to paste it, it did close the.
Mine is just right click.
Good, thank you. Thank you. And now we look in which file we need, like complicated PDB, for example. Space period means to here.
Okay, so it's copying it to the desktop. Okay.
And now if we just
Oh, this one.
It already
Shifted.
yes, but the file is here,
Okay. Thank you.
so it works, right?
Yes, I did.
It did work.
Yes, I worked.
Excellent, thank you. Works at your side? Excellent. Yeah? No? Okay, I'm ready. Let's do it step by step. Okay, and now we can, you didn't try this yet. Okay, SCP. to the so we need from this directory. And how did you save this file? What's the name of the file?
I think it's Syriac.
Let's save.
I want to copy to that directory here.
Yes, here just a dot with your current
No, this one is this. Oh.
Space period. And now we look at the it just doesn't it doesn't feel comfortable with extension.com, but we can. Sorry, I took a chair, but do save under the PDB. It will feel more comfortable. PGB. PGB. Oh, not PDF. PGB. Okay. So.
Oh yeah, I'm good. Copy and file.
Good. Just a second. Let's maybe. I will keep thinking, but time is short. Maybe we'll try to do the same from this common desktop. Just log in and see if things will work there. And if we will see that it works there and doesn't work here, we will try to identify why it doesn't want to open local connection. Yes?
Did you copy and paste? Because I'm not able to copy and paste. Like the previous one.
Mm-hmm.
Like this one.
Yeah, and also you can, yes, arrow up is copying, but you also can select. But talk to each other. On some computers, it's right of the mouse may help.
I just remember something. They don't give me access to the NDSU computers while I was.
Oh, I log in with my password.
Okay. No one can decide where to place it.
So we are done with this little red arrow about transferring files in Linux commands. So someone will probably vote to present it, right? We need to focus on clean and optimized geometry, right? And some of you already know what it is. We will cover the subject in remaining lectures before your presentations, tomorrow, Thursday, and next Tuesday for the background. But basically, when we draw molecules by hand, there is a little error from like if shaking hand, or from maybe insufficient chemical intuition on which distance to put atoms, or like I was looking around hydrogens around carbon, like sp3 hybridized hydrogens in methane, and same for silicon. Prefer to take tetrahedral space orientation, like take equal angles on all different directions. And if you draw it by hand, it's not always the case. Sometimes you just draw it like a flower, all hydrogens go into one side, and one needs to fix it. There, I'm going to like open model, maybe the same as you have created, and try to fix these human errors. There are a lot of ways to do it. The simplest one is to click on a broomstick pictogram, if you, which will, it will be not optimization. It will be just use of the standardized databases for average bond distances, and try to bring your model into some standardized way. It may generate a garbage, but for some simple molecules, it may create something close to optimal geometry. The other way to find optimal geometry, which means natural, reasonable distance between atom and angles between atoms, is similar to molecular dynamics, but without time. So instead of seeing progression of snapshots forwards in time, one finds the configuration that gives the minimal total energy. And there are several algorithms, but they look very similar to molecular dynamics. You just do steps that bring you close to the minimal energy. And the ways, the algorithm of optimization, there are a limited number of algorithms. But when you do, when you compute interatomic forces, right? If you are dealing with molecular mechanics and force field, there are tabulated forces for each pairs of atoms. And this is the next simplest step. You use forces for each pair of atoms from a table, and optimize geometry based on Newton equation, or based on just interatomic forces. It's force field optimization. We will try to do it today, but in addition, there are more advanced ways to compute forces, and basically it is what we will be doing for the rest of the course. So one takes into account that each nuclei is surrounded by electrons, electrons interact to each other, and forces in simplest cases will be the same as in good force field, but ideally it will be more precise and more rich interaction between atoms. Right now we do not need to think about details. We will focus on one practical way, how to arrange it in from the Gauss view. So please give me a couple of seconds to open my files and then to do something. So like we have models, and if the model is already too nice, one can, because we are practicing improvements, and if I have a suspicion that it is too good, I can intentionally spoil it and make it a little worse than it is. So I can just select a pair of atoms and make it bigger. Click on three atoms and change their. Okay, now it's definitely not an optimal geometry. So the quickest way is the symbol of broomstick. So if you click on it, the model comes back to something that may be optimal, maybe not. So please try to just click on broomstick, and remember, wait a second, as soon as you click on it, your previous geometry will be lost. It may be improved, may be corrupt. So it is a good practice to save as many copies as possible at each step. So to judge whether geometry is good, there are some rigorous criteria, but for those of you who are taking chemistry, a lot can be judged from chemical intuition. This is not pure chemistry course, I will not touch this, but there are, with sufficient chemical intuition you can discriminate reasonable molecules from some garbage molecules. Like,
so it will optimize the geometry or no? It makes it better.
huh?
The clean comment. What should we expect from this comment? It will optimize the geometry or no? There is some
Broomstick?
No, you're killing the geometry right now, right?
What I'm doing?
So you change the geometry.
Uh-huh.
You use the killing comment, the killing. I don't know what was the name. Clean. You're cleaning the geometry right now.
Cleaning.
Yeah.
Cleaning the geometry is not optimization, is an simplified analog of optimization, which we cannot trust. We just create a better initial guess for subsequent optimization. So never trust a cleaning of geometry. It's only a tool which is not super trustable. It just simplify your life for the future. So there is a button, Gaussian calculation setup, and this is something that we will be doing for about a month and a half before we go to solid materials. So for molecules, it's a typical thing. So 1, 2, 3, 4, menu, calculate, Gaussian calculation setup. So if you click there, for like about half, a little less than half, third of a semester, it will be one of your major tools. So this window. So it is already pre-made to what you need. So you need optimization. For the curiosity, you may click and look what is inside. So the simplest calculation will be to compute energy, which means keep the geometry unchanged and using a specific method find the total energy. Basically solve molecular Schrödinger equation and find energy of the lowest ground state. If we want, maybe if you want to practice quick jobs, maybe one should start with this, but then go to optimization. Okay. Then method. If you look on the second button after the in here, you'll see a list of the methods. So I know that at least one attendee of the class knows meaning of the abbreviation of this CCSD. We will do something a little simpler here, and today we will select only mechanics. Mechanics means force field means forget about explicit treatment of electrons and do basically what force field programs do. Those who do force field and molecular dynamics may have a laughter inside them, because there are much more efficient and optimized programs intentionally designed for force field and molecular mechanics, molecular dynamics. The Gaussian is not primary tools for that. It's just one of the options there. But it is quite universal, so that if you select this software, we do not need to learn new software each day, each week, and we can do several, illustrate several methods and several protocols in the unified system. So by definition it tells DFT, but we need to go to the molecular mechanics. And then those of you who do force field may recognize some of these abbreviations, like AMBER, right? Those who do bio-related polymers often do AMBER. And after you select those, 0 is for charged neutral system, and then it should be singlet in ground state. Then typical way is to click submit the job. So you click submit, and it will offer you to save the Gaussian input. So before I run, I may want to modify the name so that it will be self-speaking. So I can tell that it will be energy and it will be force field. And then before I do a couple of next clicks, right now we are going to, I wouldn't say misuse, but overuse this little server. It's not intended for big calculations, so we'll do it like few small molecules just for learning purposes. Starting from the next Wednesday, we'll start using more powerful computational facilities. So what I'm going to show will work, but do not plan on following the steps for your research projects. You will be offered something more powerful facilities. So you click save, and then it tells submit the following to the Gaussian, and you click OK. There is a little secret that some of you already know the answer, and it's not a big secret. It's just an arrangement of these computational tools. So this mouse-operated drawing program is not a computational chemistry program itself. It's only like a translator and a shell, an environment. But the actual code that computes things is a little boring thing that reads only text files and outputs only text files. And when one tells submit, it means it passes control from this drawing shell to actual program on this cluster. This is quite comfortable, but it is not common. And in a second I will tell what happens on the screen. It's very comfortable but not common, because if you start to work with productive models of decent size, then it will not work on a smaller servers. And on a bigger clusters, the system administrators intentionally disable all mouse-operated commands, because if it is a powerful system with like 10,000 users and each of them will try to use visualization tools, it will overuse resources. So it will use resources of supercomputer for processing graphical information instead of using computer power. And the environment that we are observing right now is not standard. The same as for transferring files that we practice today. There is a simple way, and there is a more standard, which is a bit painful. Right now, we are going through a simple way. Probably, and I'm not sure if we will have energy and time to do painful way today, but next Wednesday, I promise you, we will do the same job in a more standard and a little less pleasant way, but which will be your asset for productive research that you may want to do. So, since the job was quite simple, it was just find total energy for a single geometry, it shouldn't take too much, especially with force field. And very soon, this environment is Gauss view, is drawing program, and the actual computational tool is Gaussian. So Gaussian does its job and signals back to Gauss view that the job is complete. And then this window pops up. So I can just open it, and it will look the same if you didn't modify the geometry, but then in the results, one can click on a summary, and it will show total energy. So only this number makes sense. And if there are no electrons, if it is force field, it's typically it's often a positive number, and the atomic units is system of units that we are using in class. System of units where 1 unit of energy is 27 electron volts, and this system of units is comfortable because their all equations are much simpler. Like in the system of unit, Planck constant, electron mass and electron charge are ones, but there are standard conversion factors to go back from atomic units to kilocalorie per mole or to electron volts. So one of the ways is to record this number either on the computer or on a piece of paper, modify certain bond lengths, and do the same job again, and record this number again, and then manually try different geometries and find the one that will give minimal energy. If I do the same, I will be a cyborg. Half person, half human, half computer, which is not very efficient. We can trust computer and let it try to optimize all distances automatically. It will be the next thing that I'm going to do, but please try to do this operation, and it doesn't have any scientific value, but it will be really helpful if you try to do it. So submit single point energy job with force field. And we are on the recording. I'll send you, so if there will be something. It happens. Let's check. So let's do broomstick first. Okay. Just a second. Was it the same problem there, or you solved it?
Yeah, there's the same problem here. I won't connect these really remote.
Huh. Then we are doing something. And you close it here, right?
Yeah, closed it before I left. Tried to be open.
press return to start a local terminal. Good. Let's try here. And here, by some reason, it doesn't. Okay, well, at least we solved it here.
So,
Let me just show and then. So now here we are on the desktop, and then I can do SCP. And then if I look into cyclosil, okay. So SCP, user, host, path, then name of the file. I'm just taking an example. Space, period. And now if you look here, it is here.
okay.
Okay, so at least you know how to do it, and I'll keep thinking we'll probably recover. But you were able to copy it by just clicking, dragging.
Yes.
Okay, at least you have something. And for the rest, it doesn't matter which computer you use. Yours are here. So if you do. And under which name did you save your example?
For we work on today, it'd be homework, H3U2.
Okay. So,
I had the rest of it done, but I had the rest of it done without it didn't get saved.
Saved?
Yeah. If you see, I actually took a screenshot of it.
Okay. But, so from your chemical intuition, you see that it is not quite.
Yeah.
So we may try to do this cleaning, and if it doesn't help, we may carbon tetrahedral. If we it should be silicon, not carbon. Silicon tetrahedral. So it changes it a little bit, and now we can do it. Boom. Okay, and here this is slightly corrupted probably because it is bonds are this one are not conjugated. You may click and tell it to be conjugated. Click, make it conjugated. Okay, and do this broomstick once again. A little better, right? And now you can do everything that everyone else do. Constant calculation setup, energy method, mechanics, UFF, submit, save. And then you read here results summary. You have total energy. So now you're ahead of the class. I think we can fix it just by silicon tetrahedral.
Because of their orientation.
Oh yes, this orientation is could be key. And now let's try it once again. Energy method, mechanics, UFF, submit, save. Let's do it. Does it work?
I'm getting errors, I don't know why.
It may give errors. I'll make a full circle. Let me make a little comment of common errors. So if chemistry is not your major, but intuitively you realize that if atoms are closer than optimal distance or further from optimal distance, energy will be increasing. But also if angles between bonds will be far from optimal, it also will be very strange, uncomfortable. It's like if someone ties hands for a person. So molecule will have very high energy and unstable. So if some of you are getting errors, it can be consequence of the unnatural initial configuration. So one of the ways to fix, for example, tetrahedral arrangement of silicon to hydrogen bonds. So some of you may not have this error is to click for silicon atom, make it silicon tetrahedral, and then in your model click in the center of an atom. For example, if your angles were very wrong, right? If you do, if you tell once again that you want to do silicon tetrahedral and you click on this atom, it will automatically put it in the most reasonable configuration. Just, I will make a full circle and try it.
All right, if you change the different structure,
Mm-hmm.
it will work.
Just a second.
Use some default classes that
Still error?
Yes.
Okay, let's check. Let's do what I've taught to everyone. So silicon center. No, let's just click one by another. See, it turns those. Here you have 1, 2, 3, 4, and 5. It's not right. It should be 3. Bigger distance, symmetric. And if I click here, see, now they all look on the bottom, but they should be equally spread. Up. So this is fixed. No, it's still not ideal. Let's click the. Okay, it's better. The starting point. Yeah, and now let's try and try to optimize. And here, I think it should be single bond, not the triple. Okay, once again broomstick. Okay, yeah, I think it is very good initial geometry. Hey, see you. So if your schedule mandates you to leave, please save your latest geometry. If you log out without saving, it will be not saved, right?
It's sent to you through email.
Huh?
The homework you mean or no?
Homework is sure I will be very happy to get it, but for your own like efforts, if you modify your structure, save it before leaving. Okay, let's try to run it now. Okay, calculation setup. So optimization is too hard. Let's do energy, method, mechanics, UFF. Okay, submit, save, reactants, UFF, save, submit to Gaussian. If you are impatient, it shows here current jobs. It shows that it is running. Job terminated. Okay, it's still. But we'll find out what is. These two things are too close to each other. Maybe we need to help them to depart. Distance from here to there, and we need to move the translate group. Okay. And here can be conjugated bond. Okay. And no, let's do it once again. Conjugated bond. Okay. And here you can do. Should be double. Okay. Let's optimize it with broomstick once again. Okay, and now let's try to submit once again. Wait. Energy. Okay. İri. Interesting. I'll help others and then return. But you may just to be sure that just as an example.
Okay.
shows total energy. Who is next?
I just have a quick question.
Yeah.
So after the minimization, it's not minimization. There will be two files, the log file and also
And
the
check.
CH. Yeah.
Yes, yes.
So what's different between the two formats?
So the log file is file with results. It is a good file that meticulous human can read through. It's some reasonable information. You can open and see what is inside. The check file is binary information for robots, for computers, and it saves a lot of intermediate information. For example, if your computational job is too long and your computer system is not permitting you to compute long jobs, you can like do half of a trajectory, save everything, and then restart from there to continue. It helps to organize things, and later on it also contains a lot of information about shapes of orbitals that we will use.
Showing the errors.
Huh?
Showing the errors.
Showing.
It's not showing the result.
Oh, okay. But we will continue, and I think what we did is almost enough for the presentations on the skills. Did it work? Do you have
Yes.
no errors?
Yeah, like sometimes, but sometimes it doesn't work.
Okay. Okay, good.
Okay.
So I think everyone is tired, and let's complete it today. So looking forward to see you in class tomorrow, and I'll probably question who wants to take the remaining points through email, and we'll make sure that all questions for presentations are covered during the next Wednesday.
So how many slides is gonna be?
How many slides can you explain in 4 minutes?
4 minutes. I have to send you the slides before the midnight.